Hello everyone, today I will explain our C++ program that simulates a FIFO page replacement algorithm for virtual memory. Before we dive in, note that the code's memory arrangement differs slightly from our class approach. In class, we mimic a queue where new pages are appended and the oldest is at the front, while our code uses a vector shifting pages right, making the last position the oldest. So before that, I'm just gonna give you guys an overview of our program. So this program takes the number of memory frames and a sequence of page numbers as input. It uses the FIFO strategy to manage pages in memory, tracking page faults when a page isn't found, and calculating the hit rate. The output shows each fault and the final statistics. So this code includes libraries like IOStream for input-output and vector for dynamic arrays. In main, it prompts the number of frames stored in available and initialize vector frames with -1 for empty slots. It then reads page numbers one per line until the user's ends input, converting each to an integer with this line. Next, for each page, the program checks if it's in frame. If found, it's a hit and nothing changes. If not, a page fault occurs, incrementing faults. Unlike our class queue, where we append new pages, the code shapes all pages right in the vector, placing the new page at frames 0. This makes the last position at the oldest, which gets overwritten next. After each fault, the program prints the page causing it and the current memory thread showing frame contents. At the end, it calculates the hit rate by dividing the total pages read and displays it with two decimal places alongside with the total faults. And that is all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. My name is Radin and I'm going to explain about the LRU algorithm inside this code. So let's get ahead and look at the first line. We have the integer available. So for this line of code, we are prompting the user to enter the available frames that they want. So if they want 3, so they can just enter 3. Then we will see frames in last use. So frames here is to represent the vector of how many page that we want to store inside the current memory. And then for the last use is where we use hash map, and we use it to keep track of each page that was last accessed. And this will allow us to make LRU works properly. Next, we see faults, read, and time. So faults here is to count how many page faults occur. And then for read, it tracks how many pages that have been read. And lastly, time is for us to increment the time passed for each time we access or we want to access a page. And then we see that this while loop is for us to not get messy and handle inputs properly from the user. We will see it in the output section later. And then for how we handle page hit or miss inside this code is that we use bool found, which is equals to false, for its initial value. Then this loops next after it will check whether the current page is already in the memory. So if it's true, then it means it's a page hit, and if it's not, it is a page fault. So for the page fault, it will increment the fault variable and will give you the output like this: page, the current page, and then cause the page fault. It will give the output to the user for us to be informed. Next, we're going to evict the LRU page inside this if loop. So if the memory is full, we need to kick the page out. So they will scan the memory using this for loop, and then it will pick the page with the oldest last use time. And then for us to remove or insert the new page, they will use this for loop. It will remove the page that has been selected from the memory and add the new page at the end. So as if it is simulating the loading of the memory, loading the page into the RAM. Usually we use RAM, right? So yeah. So now in this line of last used for the index of current page equals to time, we're just going to update the timestamp. And then this code here is to inform the user that the current memory is so on and so on. So using this for loop, it will print the current memory inside the vector. Next, we will see that from this line, we're going to calculate the page faults that has happened, and also how many hit rate that has occurred. So this is all from our code. So basically, it allows us to actually think of how FIFO and LRU can actually be efficient in scenarios that they are suitable for. Doesn't mean that one is better than the another. It's just the circumstances that can give them the most beneficial optimization for them. So I think that's all. Thank you.
Assalamualaikum, my name is Siti Nur Amira. For this project, I will explain the FIFO output using two different reference strings and I will do a comparison after that. So let's start with a reference string 1 using a 3 memory frames. So before that, there is a rule in the FIFO algorithm. The first rule is don't duplicate values in memory. And the second rule is between the first and second value, there shouldn't be any repetition. So this is how it works. So this is the reference string. So I start by entering pages 1 to 3 into the memory. Since the memory is empty, so there is no issue. When pages 4 comes, it replaces 1 that following the FIFO order that always remove the oldest page in the memory and replace with the new one. For this situation, 1 replaced by 4. Then page 1 to 5 come in and replace the oldest pages. When page 1 comes again, it's already in memory, so no fault. Same goes for page 2, the follows rule 1. The rest continue with a replacement for page 3 and 4. And finally, page 5 doesn't cause a fault as it's already in memory. So the total page fault equal to 9 and the hit rate is 0.25. So this is a reference string 2, just like before we applied the two FIFO rules. So this is how it works. Pages 1 to 3 enter the memory, so all cause fault. And then page 1 comes again, but it's already in memory, so no fault. Then page 4 replace the oldest, which is page 1. And page 1 comes back and replace 2. Page 2 enters and replace 3. So next, page 5 replace 4 and page 6 replace 1. Page 2 is already in memory, so no fault. Page 1 enters and replace 5 and then page 2 is already in, so no fault. Page 3 replace it and finally page 7 replace 2. So in total, there are 12 page 4 and 2 hits. So compared to the first string, the total is 9 fault. Why this one costs more pages? 12 faults. To conclude, so although both use FIFO and had 3 memory frames, reference string 2 caused more faults because it had more switching and less use of the recent pages. So this show the FIFO performance really depends on the page access pattern.
Hi, my name is Uday Darshini Anak Perempuan Prakash and my matrix ID is 823CS5047. So today I will be explaining the least recently used algorithm using the previous string that we used in the FIFO algorithm as well. So we have three frames in memory, and when the rule is that when a page comes, if there is still space, we will load it. If the memory is full, we remove the page that was used the longest time ago. So why it happens? Because it keeps recently used pages in memory and removes the older ones. So I have input all this number here and the number of available frames as 3, and now we will dive into the explanation. So step 1, the page 1, memory starts empty. Page 1 is not in the memory yet, so the page is fault, and it will load the page 1. So memory becomes 1 and 2 empty memories. Step 2, we load page 2 and it is not 2 is not in the memory yet, so page fault, load page 2 into the memory, so it becomes 1 2. Step 3, page 3 is not in the memory yet, page is at fault, so memory is loaded, it becomes 1 2 and 3. And step 4, page 4 is not in the memory, so page fault, memory is full, so we remove the oldest used page, which is page 1, and memory becomes 2 3 and 4. Step 5, page 1 is not in the memory, so the memory is also already full, so we do the same thing, so the memory becomes 3 4 and 1. Step 6, page 2 is not in the memory is full, so we remove the oldest used page, which is page 3, so now it becomes 4 1 2. Step 7, page 5 is not in the memory, the memory is full again. So oldest used page is page 4, so the memory becomes 1, 2, and 5. Step 8, page 1 is already in the memory, so the memory stays the same, 1, 2, and 5. Page 9 also same, 2 is already in the memory, so memory stays the same. Page 10 is step 10, page 3 is not in the memory, so it removes the oldest used page, which is page 5, so the memory becomes 1, 2, and 3. Step 11, page 4 is not in the memory, so we remove the oldest used page, which is 1, so memory becomes 2, 3, 4. And lastly, page 5 is not in the memory. The memory is full, so we remove the oldest used page, which is page 2, and now the memory becomes 3, 4, and 5. And finally, the number of page faults are 10, and number of hits is 2 times. So basically, like when page 1 and page 2 came again, so that's why number of hits is 2 times. So the hit rate is about 0.17, which means about 17% of the time the page was already in memory. So basically, LRU always keeps the most recently used pages and remove the page that we haven't used for the longest time. Okay, so now I'm going to explain the same LRU algorithm, but this time I will use the string 2 from FIFO algorithm previously. So same rules apply. When a new page comes, if there is still space, we will load it directly. If the memory is already full, we remove the page that was used the longest time ago. So step 1, I entered 1. So memory is empty at first. Page 1 is not in memory. So we load page 1 into the memory. And step 2, we will load page 2 into the memory. So the current memory will become 1, 2. And step 3, page 3, we will load page 3 into the memory. So current memory we have 1, 2, 3. Now all the frames are full. So step 4, I entered 1. So page 1 is already in the memory. So nothing changes, it remains the same. Step 5, page 4 is not in the memory. So memory is full. So we remove the oldest used page, which is page 2. So load page 4 and the current memory becomes 1, 3, and 4. Step 6, page 1 is already in the memory, so nothing changes. Memory stays as 1, 3, and 4. And step 7, page 2 is not in the memory, so we remove the oldest used page, which is page 3. So current memory will become 1, 4, and 2. Page 5 is not in the memory, so we remove the oldest used page, which is page 4. So current memory is 1, 2, and 5. Step 9, page 6 is not in the memory, so we remove the oldest used page, which is page 1. So we get 2, 5, and 6. And step 10, page 2 is already in the memory, so nothing changes. Step 11, page 1 is not in the memory, so remove the oldest used page, which is page 5. Current memory we get 261. And step 12, page 2 is already in the memory, so nothing will change. And step 13, memory is full, so we remove the oldest used page, which is page 6, so we get 213. And finally, page 7 is not in the memory, so we remove the oldest used page, which is page 2, and now we get this output. And lastly, the summary is that the total number of page fault is 10, and the number of hits is 4 times when page 1 and page 2 repeated, so they were already in the memory. And the hit rate is about 0.29, which means roughly 29% of the time we didn't need to load a new page. So what is the difference from the previous run? In the previous example, there were fewer repeated hits, only 2 hits and more page faults. In this run, the same pages came back more often, like page 1 and page 2. So there were more hits, around 4 hits, so which increased the hit rate around 29%. So the reference string this time had repeated requests for page 1 and page 2 close together, so the LRU could keep them in the memory longer, reducing the page faults.